So calculate the weight of the entire apparatus. So it's got this much, so this is 2 newtons. It's got this much water and a rubber ball of 3 newtons. Okay, so if it has that much water, and you know that 1 cubic meter is equal to 1,000 kilograms, which equals about 10,000 newtons. Yes? That makes sense? So all you're going to do is just multiply this by that. And so then that's going to knock out the -3, and it's just going to make 50 newtons. So then the weight of the entire apparatus looks to be about 55 newtons. But that's off the top of my head, so let's see. Top of my head is rather poorly shaped, so let's check. Hey, cool, that worked. Okay, so that's nice. And we go on the dot below that represents the ball, draw and label the forces, not components. So the forces, obviously, one force we have is, Kevin, what? That's it? Okay, what points? Up, very good. That's F sub B. Next would be what, Trini? Gravity at points. Use a different color. F sub G. And that's it, right there? Oh, very good. I'm trying to be animated. I don't know if it's coming out animated or just creepy, I don't know. I know. I really need to get a class first period that's like, no, joke telling or something. So something. Anyways, are we good with this? Okay. So that's those. Then I don't even think we need to check that. Then for C, calculate the buoyant force exerted on a ball by the water. So then you should be able to say sum of the forces is equal to 0, right? And then up was FB, and that should be equal to FG plus T, right? And they wanted that buoyant force, so that's fine. And I think they told us the tension and strain, didn't they? Yeah, so they told us the tension, well, they told us the density too, so you didn't do that. So then that lets us say that FB is equal to FG, is it a 3 Newton ball? 2 Newton ball, plus the 4 newtons of tension. Was it 4? I don't know. Oops. Sorry. Clear speaking. Hey. Nope, we lost. In 4. Yeah. C'est la vie. We're 3rd. So we're probably going to go face like Arcadia or Burroughs or something like that. Yeah. No, I think because they beat us in 4, I think South Pass became 2nd. Yeah, because TC beat us in 5, or well, TC beat us in 3 and then lost in 5. But then South Pass beat us in 5 and 4. They didn't beat us in 3, so because of that, TC's the champs and South Pass is the 2nd. Okay. Alrighty. Bye. Thank you for making me relive that horrible experience. Yeah. It's what? Oh, thank you very much.
Yeah, the ball.
The ball. Oh, okay, way back here. So this is 3 newtons, and then that was 4 then, right? So we get like 7 newtons. That seems too easy. Can't be that easy. Is that easy? Yeah, it's that easy. They're giving us points. Okay, then calculate the pressure due to the liquid, the gauge pressure at the bottom. Remember, like, gauge pressure was the one where it's just it's the one where you can follow their advice. The effects of atmospheric pressure may be neglected, right? Gauge pressure is just the weight of the water above you. They said that the water fills the beaker to a depth of 0.2 meters, and what they want. Oh, at the bottom. Okay. I'm like, I thought it was calculate the pressure on the ball. And I'm like, I don't know the pressure on the ball. Yeah, so at the bottom is no worries, right? Because then that's just going to be pressure is equal to rho GH. Okay, so that's easy. Ba-bing. And then the string is cut, the ball rises to the surface and floats. Indicate whether the water level is higher, lower, or the same after equilibrium is reached. Interesting. Okay, you have to vote. How many? Well, you know, you looked up the answers. So, yeah. So is it higher, lower, or the same? Why would it be lower? Yeah. Have you ever taken a bath?
Yeah.
No.
No, seriously. There are some people who have never taken a bath in their memory. They only take showers. I don't mean like you ever bathe. I'm saying sit in a bathtub, right? When you get up, what happens to the water line? Ding. Just makes sense. Right? And then what you would say is that the ball, right? What we don't know. I don't think beaker, water, rubber ball weighing 3 newtons. Oh, yeah. What we can say is we don't know. That tension, force, force. I guess we could find the weight of the ball, couldn't we?
It has a weight of the ball.
It does have a weight. I mean, the density of the ball or the volume of the ball. No, we can't find the weight of the volume. If we know the weight of the ball.
You can just assume because
Yeah.
it says buoyant forces.
Because we know the buoyant force and we know the mass of the ball, so we can actually find the volume.
No, it'll break the surface.
Yeah. Well, what you can say is because the tension is greater than 0. All right, that means the ball, the density of the ball, and that's the density of the ball is going to be less than the density of water. Does that make sense to you? Because if the density of the ball was greater than water, what would the ball do? It would sink. There would be no tension in the string. So, because of this, right, the tension is greater than 0, so it's therefore this is true. And if this is true, therefore the ball floats, right? And if it floats, then you can say that part of the ball is above the surface. And if part of the ball is above the surface, then that means that the overall water level will go down. Because the volume of the ball is no longer inside the water. Right? Does that make sense? Technically, you can say because the tension is 4 newtons, and it's very much larger than the mass, the weight of the ball, almost the entire ball is going to be out of the water. Right? So that's what I would do. I would say if the tension is greater than 0, therefore the density of the ball is less than the density of water, therefore the ball floats. Okay? Now, if the density of the ball and the water were the same, then it would float like right on the surface. Right? But because it's less, that means boom, part of it is going to be out of the water. And because part of it is out of the water, then the water level will go down. Yeah.
I have a question for part D. What are the units of pressure? Kilopascals or regular pascals?
Usually just pascals, but it's fine. Because like what you usually do is you do like 1.01 times 10 to the 5th pascals. That's like atmospheric pressure. Now, yeah, I would say the only thing that you want to use a prefix on is kilograms. Alrighty.